When we're given a relation, that relation may look like we're looking at a graph, or it may be a set of data points. And when we look at it, we want to test to see, does every x belong to a maximum of one y? This x cannot belong to two different y values. If these are different values, an example, if 4 says, hey, it belongs to 5, and so we're used to seeing that as an ordered pair. Okay, yeah, 4 maps onto 5. This is my input, this is my output. Awesome. If 4 maps onto a different value, regardless of this value, if it's any number different, any output that's different than the original, so this is 4 maps onto 7, this is no longer an example of a function. So every x must belong to at most one y. Now what you can see is this is often confusing for kids. We're used to see this as an x, y setting. So 3 can go to 2, 4 can go to 2, 5 can go to 2, 6 can go to 2. A lot of times students see a set of data points like this and they say it's not a function. So different x values can map onto the same output or y value. We just need to make sure that if 3 is repeated again, it can only belong to 2. So if I see 3 again, it has to go to 2, and then it's a function. But if I see 4 again and it goes to anything other than 2, it no longer is a function. Now, when we look at a graph, we learned back in middle school and possibly in 9th grade about looking at a graph. Let me just draw a very simple one here. Let's do some type of a wave curve. And we can test visually by looking, and it's called this one-to-one status, which means 1 to 1 is every x belongs to only one y. So I can make these vertical lines, and every time I make a vertical line, if I touch the function at a maximum of one time, then it constitutes as being a function. Did everybody hear that? Okay, so let's go over a few examples. So for students that are rewatching this video, I just asked the kids in front of me, does this constitute a function? I want you to recognize that this is just not random numbers. This is just not a set of random numbers. It's a set of ordered pairs. And so if you prefer to look at it like this, I have -3 maps onto 5, 7 maps onto 2, -4 maps onto 4, and 5 maps onto 3. We're checking to see, does this relation constitute a function? So here's the quick trick to do this. Does the x values ever repeat itself? If they never repeat itself, yes, it's an example of a function, because every x maps onto one and only one y value. Okay, done. Okay, here's our next one. Let's do another one out here. Now, what we need to recognize when we go on to a standard test like this is there's multiple ways to show functions. So I'd like you to write down this one. I want to know, is this a function? So what this is saying to us is this is a really fancy way of saying, hey, we're going to take the x and y's that are specific to this equation, and we want to determine, is it a function? That's all it's saying. So how do I think of this? Well, I know I can quickly graph this. I start at +1 on the y-axis, not the x-axis, and then I use a slope of 4 over 1. I'm going to go up 4 over 1, up 4 over 1, up 4 over 1. I draw my line through those 3 points, and now I'm able to look at this and say, yes, I know this is a function. Why? Because every x maps on to a maximum. In fact, it maps on to exactly one y value. Thumbs up or thumbs down if you understand that. It's just a fancy way. It's a fancy way of me just giving this to you and saying, is this a function? That's all it's saying. For the x and y's involved in this, is it a function? Okay, let's think of 2 different ways that we could talk about this. One is if I want to take this and I want to think about graphing it, first I need to isolate the y. So I'm going to take the square root, but how many different answers will I have? 2. So one time I'm going to graph this function with a positive, and the next time I'm going to graph this function with a negative in front, okay? And when I do that, and you graph it, you would recognize that this is not actually going to be a function. So we cannot use our calculator for this part of the exam, but I do want to show you really quickly how this works. So if I go 2nd plus 7, 1, 2, this is quicker than me doing it. I come over here, and I plot, so we have a positive, the square root of 4x, and my next function is going to be the negative square root of 4x. And I graph these 2 functions, and why does this not constitute a function? Turn to your partner and look at this. Why is this not a function? Doesn't pass the vertical line test, which says what? Every x can belong to a maximum of how many y's? 1. And does everybody see here that it would belong to more than 1? More than 1. Okay. Is there another way to do this without the whole graphing thing? You don't have a graphing calculator. There is. Let's come here. So I want to come up with a perfect square. So perfect squares we know would be like 1, 4, 9, 16, 25, 36, blah, 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 blah. What number could I take times 4 to get one of these? I could take 1. Do you guys agree with that? So if x equals 1, okay, if x equals 1, I get 4 on the right. Yes? If x equals 1, I get 4 on the right. What squared could give me a positive 4? Because they have to equal each other. Okay, 2. Thumbs up, thumbs down if you agree. Who can tell me another one that would work? Let's try that. If I plug in 1, I get 4 on the right. But if I take negative 2 and square it, I still get 4. So 4 equals 4. I can plug these in and it works. I can plug these in and it works. This shows me it's not a function. Why? Because x's belong to more than one y value or output value. Now, I just came up with, a student gave me a random number of 6. And I have 6 maps onto m and 6 maps onto p. I just came up with some random values for m and p. If I tell you that these two particular points are part of a function, what do you have to know about m and p? Turn to your partner. If I tell you that these particular points that belong to relation are in fact a function, 6 maps onto m and 6 maps onto p. What do you know about m and p? To your partner, go. If it's a function, what do we know? Do these have to be the same or different? If this is a function, do these have to be the same or different? They have to be the same, so m equals p. Okay, m equals p. Now let's flip that around. What if I said m and 6 and I said p and 6? Does there have to be a relationship between m and p for this to be a function? So let's go like this. Let's go like this. Go x and y, input, output. So m maps onto 6 and p maps onto 6. Does there have to be a relationship? Do these have to be the same? Do they have to be different, or does it not even matter? It doesn't matter, because every input could map onto the same output. We could have that. Okay, we could have that. All right, you ready? Let's go back, and I'm just going to have you watch really quick. I'm just going to come up right now with a set of ordered pairs that belongs to a function. It represents a function. So 1 goes on to 2, 3 goes on to 3. I'm making this up here. 5 goes on to 4. And we're going to say that 7 maps onto 5. Okay, this is a function that I give you. And then I want you to write down the domain. So turn to your partner and verbalize, what is the domain if I tell you this is a function? Go. What is the domain? The domain is just the x values, 1, 3, 5, and 7. So I want to know, if I just list the domain, is that a function? To be a function, you have to have an input and you have to have an output. Is there an input and an output here? No, not at all. Okay, and this very last one. With your partner, I want everybody to write this down, and this is going to be at 20 seconds. Don't get overwhelmed by what this looks like. If I tell you, let's just come up with some random. Let's say this is g. So this is what g of x equals. So realistically, by the way, when I see this, all this means is that g of x is equal to y. That's all it means. So I could say g of x is equal to the function 2x minus 3. I want to know, is it a function? And how do you know? Ready, get set, and go with your partner. I'm going to give you 30 seconds. I'm going to press pause. Is this a function? Let's try. So how can I clarify this is a function? Well, one way, we don't have a calculator, would be to graph it. So I'm going to start at -3, 1, 2, 3, and I'm going to use the slope up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, connecting those points. Does this linear line represent a function? Yes or no? And now, other than just yes, you have to explain. What would be your explanation? Every x maps onto exactly 1. You're going to start by talking about how could I represent the domain and range of this function in 3 different ways. I definitely want you to write this down. Domain and range. And why is this? If you are provided with the opportunity where you are actually writing things down, wonderful. You write it in the correct mathematical way that makes sense to you. But if it's multiple choice, you have to recognize there can be different forms that the test provides to you. What's different about your test, bless you, versus the other AP test that you may be taking this year is this is the very first time that this test has been provided. And so we have no other previously released exams to look at and go, oh, okay, this is the format they're using. We have some practice exams that have been created, but we have nothing that's official that we can look at a previously released one. So when I look at the domains and I'm looking at this function, that means on this graph, where are the input values that are going to model what I have? So it starts at 1. One way that you probably learned freshman year is, okay, x values are greater than or equal to 1. That's for domain. Yep, that works. Now, this year we learned to write things, bless you, in interval notation. That means I need to include 1, and then it's everything to the right. You need to know all of the different forms that we go over because you don't know which one's going to be presented. Now, here's another one. You ready? Please write this down. So all x's such that x is greater than or equal to 1. This is the domain here, and this is how it writes. The domain, we're going to call this function f, okay? The domain of f is equal to this. The domain of f is equal to this. It's fancy, but I want you to recognize it. Let's look at the range. So my y values, it goes down as low as 3, and then everything is above. So y is greater than or equal to 3. It's greater than or equal to 3. Or, okay, range of function f is equal to all y values such that y is greater than or equal to 3.